Welcome to Fun with Physics, and today I'll be playing with toys that I haven't used since I was 6. But the reason is they're perfect for Rube Goldberg machines. Let's show you how they work. Alright, so let's break it down. All Rube Goldberg machines have an objective. They begin with however you want, but at the very end the machine performs a task that you want it to do. It performs work. So what we're going to do today is when I wake up in the morning, my alarm on my phone's going to go off. And immediately I'm going to get back and pick up my phone. In picking up my phone, it will release a baseball down a ramp, which will trigger a bunch of events, which will lead up to dumping cups of dog food into my dog food's bowls and feed them. So I think this is kind of cool because, every morning I have to feed the dogs. So this is just an easy way to feed them. And, it's a cool way to show how physics works. And, yeah. Today, me and Dahlia made a machine. A machine is a device for multiplying forces or simply changing the direction of forces and kind of playing with energy. The principle underlying every machine is the conservation of energy. Conservation of energy is, energy cannot be created nor destroyed. It can only be, manipulated. So within this Dog Feeder 5000, we have a bunch of mini machines. One of the simplest machines, for example, would be a lever. We see this lever system with the ball and the glove, and it tips the books over, hits the golf ball. I'll go into that later. But when work is done on one side of the lever, and then the same amount of energy is put on the other side of the lever, is the output. We also see this with another very simple machine, a pulley, which is demonstrated in our machine as well. So there are two major forms of energy used in our machine. One of them being potential energy and the other being kinetic, and they work hand in hand. Potential energy is mass times gravity times height. And when you have a really heavy object on a ledge, like the coins here, it creates a lot of potential energy. When that potential energy transforms into our other form of energy, kinetic energy, it does some damage. Kinetic energy is 1/2 mass times velocity squared, and the potential energy of those coins up there, when they fell, the potential energy transformed into kinetic energy, and that energy was equal to each other, and this is the conservation of energy. So this contraption also deals with the work-energy theorem. And the work-energy theorem is that work is the change in kinetic energy. Our project also has a lot to do with momentum. And momentum is demonstrated in a lot of our little devices we have here, all set up. And I'll go into that more up close so you guys can see it. And I'm running out of things to talk about, so I'll just take you through how everything works out. So here's the beginning. After the alarm goes off, I'll pull it off, releasing the ball, turning its potential energy into kinetic energy, and the ball will continue down and fall off the header of my bed. So the baseball will drop into this glove. This glove has a bat inside of it, and it will be like a lever. The glove will go down and lift the other side of the bat up, pulling the books up and creating a little slope, so that golf ball there can roll down and hit that track piece. And that track piece will trigger another event. So that track piece will knock these two little cars down. One entering this cup right here, which we'll get back to in a little bit, and the other car will go into Good Will Hunting, an Academy Award winner featuring Robin Williams. This will create a domino effect which will hit this ball down the stairs. So this cup right here on the ledge is the cup full of coins and is tied to the ball, which is now rolling down the stairs, and it will pull that cup down, and then since it's tied to a pulley through to the other cup, it'll pull the lighter cup with the car in it, and it'll fling it up into the air. And it'll fling it up into the air at the same speed as that cup is falling. And that cup is falling pretty fast, 10 meters per second squared, as we learned in physics. And the cup that is flung up into the air will hopefully hit the zip line. And that zip line will trigger the Terminator down to continue the contraption. And if it goes as planned, the cup with the car in it will fling up and hit this zip line right here, which the Terminator is on. And here's the man of the hour, the Terminator. It's pretty cool. He is holding onto a straw which reduces friction on the rope. And when the zip line is hit, he falls off the little ledge he's on, and he continues down the zip line, which will hit an object, continuing the contraption. So the Terminator will run into this toilet paper here, which is around the zip line, and it has a string attached to it, which is attached to another track piece up on the box over there. The track piece is holding up the train, which is on an incline. So the train has a potential energy facing down, but the track piece is stopping it. And when the Terminator hits that roll, it will release the track piece. So when that track piece is released, it will release the train. The train will convert its potential energy into kinetic energy and will continue down the slope and hit the spike right there, which I made from another track piece and a sharp piece of metal there, and it will pop the balloon. So a string around that balloon will be released after that balloon is popped. Those strings are connected to two folders, which I'll show you in the next picture. The piece of string goes through this hole in the door, which is where the lock used to be, and it's connected to these two folders. And so when the balloon is popped, it will relax the tension on the string. The folders will drop, releasing the food on top of the folders down into the food bowls and feeding the dogs. Oof, alright, now that that's done, I did want to add that basically everything in this contraption uses potential energy. From the baseball, to the golf ball, the cars, the soccer ball, the coins, the Terminator, the train. It's a lot of things. And what happens is, when the potential energy is converted to kinetic, it creates a domino effect, and once the kinetic hits the potential, it's a cycle that starts over again. And it's a conservation, the law of conservation of energy. Energy can't be created or destroyed, it just can be changed around. And I think it's a cool concept, and it is exemplified in this Rube Goldberg machine. I'd like to say thank you for watching, and this has been an episode of Fun with Physics with Erik Owenson and Dahlia Hernandez. Yay for physics!